In order for us to start finding sine, cosine, and tangent or trig functions in quadrants that are other than the first quadrant or of angles that are bigger than 90 degrees, we have to be able to first find what is called their reference angle. So let theta denote an angle that lies in a quadrant that is not quadrant one. The acute angle formed by the terminal side of the angle and the x-axis. The x-axis is called the reference angle for theta, as we are going to see below. So to find the reference angle, we draw a vertical line to the x-axis and mark the angle between the x-axis and the terminal side. You may have noticed that I am overemphasizing which axis? The x-axis. We always draw our triangle by connecting the terminal side to the x-axis, never to the y-axis. It doesn't work that way. So, for instance, in this first example right here, if we take the terminal side and drop a perpendicular angle to the x-axis, then this angle that we have created in this little triangle is called the reference angle to this big angle theta. In this third quadrant, if we take and we draw a vertical line to the x-axis, this is the full angle, but the reference angle is this teeny tiny little bit right here. That's our reference angle. Here's the reference angle for this triangle, for this angle. If we look in the fourth quadrant, here's the full angle that we're looking at. But if we connect the terminal side to the x-axis with a vertical line, then we can see that the reference angle is this little guy. It's always next to the origin in the triangle that is connected to the x-axis from the terminal side. So these are all reference angles. In a angle that is in the first quadrant, the reference angle usually just is the angle unless we're doing something crazy like going in a negative direction. Okay, so this is where those angles are placed. Now, let's see if we can find what is the reference angle for some angles. So let's draw the angle 120 degrees. 120 degrees is between 90 and 180. So it's an angle out here in the second quadrant. And if we do this, this is 120 degrees. Now, in order to find the reference angle, I'm going to drop a perpendicular line to the x-axis and create an acute triangle. This little bit right here in red is the reference angle for 120 degrees. And we need to know, what is this reference angle? How big is that? And the way to figure that out is to know, well, if I started here and went all the way here, isn't that 180 degrees? But we didn't go a full 180 degrees to get to this line. We went 120. So if we take that 180 degrees and we subtract off how far we went, which is 120 degrees, what is left is a 60-degree angle, or this reference angle is 60 degrees. So we would use a 30, 60, 90 triangle to think about our SOHCAHTOA. Let's try an angle that is in quadrant 3. 225, that is an angle that is down here in quadrant 3. We went 225 degrees, which is past the 180. So how do I find the reference angle? I connect the terminal side to the x-axis with a straight line. What we want is just this much of the angle right there. We don't want all 225 degrees. That's not the reference angle. So if we think about it, this much was 180, and then we went past that a little bit more, and that's what got us to 225. So to find our reference angle in the third quadrant, we're going to take 225 degrees, which is how far we went. We will subtract 180 degrees, and what is left is 45 degrees, or our reference angle in here is a a 45-degree angle. So we can use a 45, 45, 90 triangle to do that. Okay, let's look at one in the fourth quadrant. Now, the fourth quadrant's a little odd because notice in the last two, we've used 180 degrees to help us find the reference angle. In a fourth quadrant, or let's say 330 degrees, which is how far we went. So we went all the way around here to 330 degrees. And where is our reference angle? Well, we connect the terminal side to the x-axis, and the reference angle is this little guy here near the origin. But notice if we take all of this blue and add the red to it, how many degrees did we go through? We went through 360 degrees. So we're going to take the 360 degrees, subtract off the blue 330 degrees, and what is left when we do that is our reference angle of 30 degrees. So this little guy here is a 30-degree reference angle, and we can use a 30, 60, 90 triangle to help us solve this problem. Now, that's how you find reference angles in degrees. To find reference angles in radians, it's actually much easier than in degrees because reference angles in radians are just take the denominator. That's all there is to it for our 30, 60, and 90 degree in radians angles. So 5 pi over 4, it's a plus 1. The top is 1 plus the denominator, so that puts us in the fourth quadrant. And guess what our reference angle is? Oh, it's pretty easy. It's just pi over 4 right there. 2 pi over 3, that is the denominator minus 1. That puts us in the second quadrant. And what is our reference angle here going to be? Oh, it's just pi over 3. No big deal. 11 pi over 6, that's 2 times our denominator minus 1. So that puts us in the fourth quadrant. And what's our reference angle going to be? Just pi over 6. So the radian ones are actually a little bit easier to think about as terms of what is their reference angle, as opposed to the ones in degrees where we really need to be thinking, okay, should I add 360 or should I subtract it from 360? Should I subtract it from 180 or should I subtract 180 from it? You got to think a little bit more on those.